Hi, I'm Adolph Oliver, and this lesson is about solving inequalities. Now, inequalities in many ways are like an equation, but here's the difference. Let me write one down here. 2x minus 1 is less than equal to 5. Now, the difference is, instead of an equal sign, we've got an inequality. This is less than or equals. It could be less than, it could be greater than, or greater than or equals. And one of the things you remember about inequalities is they don't have one answer. They have a whole range of answers. Now, the main techniques of solving an inequality are just like they are with an equation. There are two things we have to watch out for, but in this first example, we'll sidestep those for a moment. Now, remember, our goal, if this was an equation, would be to end up with x equals whatever number the answer is. And so, as always, we want terms with x on the left and plain numbers on the right. Anybody that's on the wrong side we have to move. And this plain number on the left has to be moved. And it moves just like it does when you have an equation with an equal sign. If you jump a single term across to the other side, then what happens is it changes the sign, so the minus 1 jumping over here becomes plus 1. Okay, well now, since we moved the minus 1, I now have 2x less than equal to, and 5 plus 1 gives me a total of 6. Okay, well, just like we do for a regular equation, what we need to do now is get a single x over here on the left. So, since this is 2 times x, I have to do the opposite at times, divide by 2. But to keep the balanced scale, I have to do the same thing on the right. The 2's cancel out here on the left. I end up with x less than equal, and of course 6 divided by 2 is 3. Now remember, what this means is any x less than or equal to 3 would be a possible solution to this original inequality up here. And since we have the equal bar here, that means a value of x equals 3 would also work, besides values less than 3, like 2.9 or 2 or negative 7 or anything like that. Now, there are two cases that you have to keep in mind here where inequalities are special. And these are cases where you have to flip the inequality sign. Let me show you examples of these. They're easy to demonstrate, and we can do it just with numbers. For instance, if you interchange the sides. Now, let's put an equality here that just with numbers that we know is correct. 2 is less than 3. Okay, and that's true. 2 is definitely smaller than 3 is. Now, by the way, remember how these inequality signs work. They work very nicely. There's a small side and a large side. They're sideways V's is what they are. The small side always points to the smaller number, the large side to the larger number. So we would say here 2 is smaller, but the more common language is 2 is less than 3. Okay, well, let me interchange the sides. I'm going to put the 3 on the left and the 2 on the right. Now, since we kept these with regular numbers, we know who's the larger and who's the smaller here. The 3, of course, is definitely larger than the 2, so we would have to draw that inequality symbol, the little sideways V, so the larger side was pointing toward the 3 because the 3 is larger, and the smaller side pointing toward the 2. Well, look what happened here. You had to flip the inequality. So when you have variables and things like that, instead of just plain numbers, you still have to flip the inequality. So this is one of the things we'll remember right here. Anytime we interchange the sides, and we do that occasionally to help solve an equation and these inequalities as well, if we ever interchange the sides completely, all at once, we have to flip the inequality as well. Now, here's another case where we have to keep track of when we need to flip these guys. And again, I can show you this with some numbers here. Let's do our same example up here. 2 is less than 3. Okay, once again, remember the small side of the inequality points to the smaller number. But now, let me multiply both sides by -1. I'm doing the same thing to both sides here. to preserve the balance. Remember, this is still like a balance scale. So what do I end up with? Well, on the left side, -1 times 2, I'll just write it over here to the right as -2. And on the right side over here, I've got 3 times -1, which is -3. Now, remember that -3 is smaller than -2. -3 is to the left of -2 on the number line. Let's just draw a little number line up here to remind you about this. Here's 0, here's -1, here's -2, and here's -3. So if we are comparing -3 and -2, notice that -3 is further to the left, which means it's smaller. So I would have to draw the inequality with the smaller side pointing toward the -3. Notice that what's happened here is we've had to flip these guys. Okay, well, if you do the same thing dividing both sides by -1, you'll get exactly the same answer here and have to flip it again. Here's the key on this. You only have to flip the inequality when you multiply or divide by something that is negative. Let me remind you, if you multiply or divide by something that's positive, let me just multiply both sides of that original guy we had here by +1. Okay, what do we end up with? Well, a +2 on the left and a +3 on the right, and guess what? The 2 is smaller. If we go back up and look at our number line up here, here's where +1 and +2, and extend it a little bit, +3 would be right there. And the 2, of course, is to the left of the +3, so that means the 2 is smaller. Notice we multiplied both sides by +1. We didn't have to flip the inequality. So the two things that we keep in mind here in working with these inequalities, we solve them just like we do equations, but there are two things we have to keep track of. One of them, if we ever completely interchange the sides, we have to flip the inequality. And secondly, if we multiply or divide, but by something that's negative, we have to flip the inequality. If you multiply or divide by something positive, you don't need to flip, as we showed you on this last example. It's only if you multiply or divide by something negative. Okay, well, one more thing to mention before we start looking at some examples, and that is to introduce the idea of what is known as set builder notation. Now, this is actually a method that gets used more in intermediate algebra, but we're introducing it to you here so you get used to it. Let's go back up and take that original answer we had up here, x less than equal to negative, or x less than equal to plane 3, +3. Let's come back down here, and I'll just write that in here. Okay, x less than equal to 3. Now, what we do is we kind of embellish this answer a little bit. It's not difficult to make this set builder notation, and as like I said, set builder notation is designed for fancier applications that you'll bump into in intermediate algebra. But right here, we can get ourselves kind of used to the idea of how it works. The first thing you do is you put a vertical line in front of it. Now I'm going to come back in a moment and tell you how we verbalize that, but that's easy enough to do. Draw a vertical line like this. Then, whatever the variable is that you're using here, we write it in front of that vertical line. Now, what the mathematicians often do when they indicate, the sets of answers is they put them in these curly brackets. You may remember when we did regular factors earlier on, we used these same set brackets and listed the answers and put commas between them. Well, here's the idea. These curly brackets make the set of all possible answers, and why they call this set builder notation is because, given this information, you can build up as many possible answers as you care to have. In other words, what this is saying is, get all the x's, and now I'm going to tell you what this vertical line translates to, such that. That's how you normally turn around and verbalize that. Okay? all the x's such that x is less than equal to 3. Okay, and this is, again, information that anybody could use to build up as many of these x's as they wanted for answers, and you'd separate them by commas in here, but we just give the information or the rules here to be able to build these, and that's why it's called set builder. Now, where you'll go with this in the future is you'll have an inequality over on the right here that'll have more than one variable. It might have an x, a y, and a z. And you may be only interested in the values of one of those letters, let's say y. Well then, what you'd put in front would be the letter that you're interested in, and then this rule would allow folks to generate other values of y. But again, this set builder notation is designed for things fancier than what we're doing, but it's real easy to make. So let's review it one more time here. Solve the inequality the normal way, come up with what the answer is, put the vertical such that line in front, whatever variable you're using, put that in front of it, and then enclose the whole thing in the curly brackets here. And how this we verbalize is a set of answers of x such that x is less than equal to 3. Okay, well, we'll use a set builder notation for practicing the answers that we come up to in the problems we're going to work. Let's start looking at some of these now. Okay, here's the first example we want to take a look at. M minus 19 is less than equal to negative 17. Now, once again, we use all of the standard methods of solving equations. The only thing we have to watch out for is if we ever interchange the sides completely, or if we multiply or divide through by something that is negative. That's when we flip the inequality. All other cases, when we're moving things, or if we multiply or divide by something positive, the inequality does not change. Well, again, our goal is the same as it is for a regular equation. We want the variable on the left and plain number on the right. The one guy that's out of place is the negative 19, and he jumps over as positive 19. Now, this is exactly like we do it when we jump terms one at a time with regular equations. When we jump them across the middle here, what we end up doing is just changing the sign. And when you move things like this with inequalities, it's like you're adding and subtracting things from both sides. You don't have to flip the inequality when you do any of this type of moving. It's only if you multiply or divide and then by something negative. Okay, well, let's see. We got the negative 19 moved. I have the m left on the left side. And let's see. Negative 17 plus 19, positive wins by 2. And there's no reason to flip the inequality, so it stays the way it is. Now, we're going to make set builder out of this. Put that such that vertical line, and then our variable's m. Put that in front of it, and then just put the curly set brackets, and there you are. The answer's in that set builder notation. Okay, now, here's another example. Okay. We've got here negative 10 is less than equal to 7 minus a. Okay, there are a number of different ways we can approach this particular guy. One of the things we can do, since this is a minus a over here on the right side, if I jump it over to the other side, it'll become a with a plus in front, which is the way we like it. So what we'll do with this one here is just keep in mind our normal things about moving. Remember, we want the variables on the left and just plain numbers on the right. Now, of course, in this case, we're going to have an inequality up here, but the idea is the same thing, and what happens. So, let's identify the guys that are on the wrong side. First off, we only want variables on the left, so the minus 10 is on the wrong side. We only want plain numbers on the right, so the 7 is okay, but the minus a has to move. Okay, let's move both of these. Minus 10 goes over to the right as plus 10. Minus a comes over to the left as plus a. Okay, we move the minus 10 and the minus a. let's see what we have left. We've got the a with the plus in front. You can write the plus or leave it off. Now, we've moved things. When you move things, you never flip the inequality. So we leave it the way it is, and 7 plus 10 is 17. Okay, well, there's our answer. A less than equal to 17. Again, to make set builder notation out of it is real easy. Put that vertical line in front, the such that line. The variable is a. Put that in front of that line, and then the curly brackets. And there we go. Okay, now, next up, we've got this guy. Negative 14x is less than negative 252. Well, everybody's on the right side. We got x's on the left. We got plain numbers on the right, so there's nobody to move. All we have to do is just get a single plus 1x here on the left. Since I have negative 14x, I've got to divide both sides by negative 14. Here it goes. Now, notice we've just divided by something negative, so before you do anything else, be sure you turn around and flip the inequality sign. Okay, notice I did that. I have it pointing the other way. You want to do this before you write anything else so you don't forget to do it. Now, the negative 14s reduce out. Okay, we end up with just an x, officially with a plus 1 in front. You can write it if you want, but you don't have to. Over on the right side here, the two minuses give me a plus. I'll put a plus here just to rub it in. Let's see, 252 divided by 14. I think if you get your calculator out and do that, I think it comes out to be 18 times. So, what's our final answer here? Well, x greater than 18. You could leave the plus in front of it here or drop it off like I've done here. But of course, we want to make set builder notation out of this. So there's the vertical such that line. My variable's x, so I put an x in front of that. And then I finish up with the curly set brackets. And remember, how you would verbalize this is the set of all the values of x such that x is greater than 18. Now remember here, since x is strictly greater than 18, 18 would not work because there's no equal bar here. Anything slightly larger, 18.1 would be fine, and values up from there. Okay, now let's look at this guy. Notice that our variable is upstairs in the numerator here, and what we've got is basically a fraction here with a denominator of 4. Now, a nice way to work this, think about this whole top, and I'll just put parens around it here to kind of indicate, that that's the whole numerator. What I'd like to do is get rid of this divide by 4 and get rid of the fractions. Well, how do we get rid of divide by 4? We turn around and multiply by 4. And you can think of this, as a fraction here. So what I'm going to do is multiply by 4 over 1. Now, notice why I'm doing this is now I can cross-cancel. These two fractions are multiplying each other, and the 4's will cross-cancel out. But before I forget, since I've multiplied this left side by 4 over 1, I got to do the same thing over here on the right side. Okay, well, on the left side, as we said, the 4's cancel out. I get 1 times x minus, or x plus 9, which is just going to be x plus 9. Now, we did multiply by something, but notice it was positive. Yeah, you only flip the inequality when you multiply by something that's negative. So since this is positive, the inequality stays the same way. Now over here, you might make a fraction out of this original 4, just to remind yourself the 4 is upstairs. And of course, we end up with 4 times 4 is 16 upstairs, 1 downstairs. Anytime you have a 1 downstairs in a fraction, the answer is just the upstairs. So we can simplify that as saying x plus 9 greater than equal to 16. Well, we're closer to the answer, but not there yet. We've got to get this plus 9 over to the side where we just want the numbers, so the plus 9 comes over as negative 9. Okay, well now we just have x left on the left side. Again, we haven't done anything to cause that inequality to be flipped. 16 minus 9, I think positive wins by 7. So x greater than or equal to 7, and of course making set builder notation is very simple. Put that such that line, our variable is x, and the curly brackets on both sides. There it is in set builder notation for us. Okay, well, let's look at this one. X divided by 3 minus 2 is greater than or equal to 3. Well, again, we want to have just terms on the left with the variable, which is x in this case, and plain numbers on the right. There's one guy that has to move, this guy right here, the minus 2, so he goes over as plus 2. Now remember again, when you move things like this from either side, one to the other, you never flip the inequality when you move things. So it's going to stay the same way it is. We end up with x over 3 is greater than or equal to, and 2 plus 3 gives me 5. Okay, well now, we got to get this x all by itself. This is x divided by 3. So what I'm going to do is multiply by 3. I'll write it as a fraction here, and I got to do the same thing on this other side. Remember, we're dividing by 3, so I have to multiply by 3, and I'm reminding myself that this 3 that I'm multiplying by is upstairs. So now cross cancel these 3's, and we end up with just x on the left greater than or equal to, and I can make a fraction out of this 5 by putting a 1 underneath, reminding me the 5 is upstairs. 5 times 3 is 15, and of course downstairs 1 times 1 is 1. So since we have 1 downstairs, the answer is just the upstairs. 5 times 3 gives me 15. So I have x greater than or equal to 15. And again, very simple to make set builder. There's the such that line, our variable is x, and put the curly brackets around it, and there you go. Okay, well next up, we've got this guy. Now, let's demonstrate something we haven't done here yet. Notice the variable only occurs in one place, and it's on the wrong side. So we could do something here to get this guy over on the other side. I can interchange the whole sides all at once. Let me do that. Negative 2 plus x over 6, and then we have the negative 3. Now the first thing to remember is when you move both sides at the same time, you don't change any of the signs. You only change signs when you jump terms one at a time, but if you change everybody all at once, you leave the signs the way they are. Now of course, since this is an inequality, hopefully you remember that if you do this interchange the side things like I did right here, then that means you've got to flip this inequality sign. So let's indicate that here. I make sure it goes the other way. Okay, now notice what we're preserving is the side with the negative 2 and plus x over 6 is largest. Notice we're still indicating that because since we put it on the other side, by flipping the inequality, we're still indicating that it's largest. Okay, well now the rest of the solving is very similar to the last problem we had. I've got to move this minus 2 over to the other side here where it becomes plus 2. Now again, when you move things one at a time like this, that's when the sign changes. And of course, we don't have to flip the inequality when we move these guys one at a time like this. So what's left on the left side is x over 6. The inequality stays the same way. Negative 3 plus 2 gives me negative 1. Okay. Well now, all we have to do is multiply both sides by 6 here. Okay, and you can make a fraction out of this if you want, or just leave it as a nice whole number, your choice in how you do it. But notice I've multiplied both sides by 6. Now, that's a positive value. We do not have to flip the inequality. If I would have multiplied both sides by negative 6, then we would have had to flip it. So remember, you only flip the inequality when you multiply or divide by something negative. We multiplied by a positive 6, so we don't have to flip it. The 6's, of course, cross-cancel here. That's exactly what we wanted. I get x now greater than, and over on this side, 6 times negative 1 is negative 6. got the 1 downstairs, so the answer is just what the upstairs is. Okay, well now again it's real easy to get set builder notation. Put that vertical such that line, our variable is x, and put the curly brackets around the whole thing. Making set builder notation in simple problems like this is definitely an easy thing to do. Now let's look at someone that we've got to clean up a little bit. It's not uncommon. You're going to run into problems like this. And notice, just like in regular equations, if we've got some parens on the side and somebody out in front multiplying it, we have to find out exactly how much of each of these terms we have, and what you use is the distributive law. So this distributing in like this is just clean up on both sides, whether we're distributing by something positive or negative. This is just working on this one side, so it doesn't affect the inequality. The inequality is only affected if we multiply or divide both sides by the same thing. Here we're just doing some cleanup. Well, let's do that. 4 times 1 is 4. 4 times negative 8a is going to give me negative, let's see, 4 times 8 is 32. So negative 32a. Now don't forget we had the plus 4a. Okay, well, what we have to do, of course, is combine some like terms here. Simplify this left side a little bit more. I've got the 4 in front, negative 32a plus 4a. Well, let's see, negative's going to win, I think, by 28, so negative 28a. Okay, well, that's less than negative 192. Okay, well, the next thing up that we're going to do is turn around now and see if there's anybody that has to be moved. Again, we only want our variables on the left. This is the a, it's okay, and only plain numbers on the right. The negative 192 is okay. So this guy on the left over here, who is plus 4, since we didn't see a sign in front, we assume him to be positive. He has to move over to the right side, and he goes over as negative 4. Okay, so what do we end up with? Once we move the plus 4, we have negative 28a is less than negative, what do we have? 196. Okay, well now the next thing we're going to do is we're going to take and divide both sides by that 28. And of course we have to divide by negative 28. Remember, we want to get a plus in front of the a, so we're going to divide by negative 28, and we're going to do that in both sides. Now, this should set off bells going here, because we are dividing by something negative. Remember, this is an inequality. If we divide by something negative, what that means is we've got to flip that inequality symbol. So here it is. It was pointing smaller to the left. We have to now draw it pointing smaller to the right. The negative 128s cancel out. I get a greater than. The 2 minuses give me a plus, so I'll put a plus here to rub it in. And let's see, I think 28 goes into 196, I think 7 times. If you get your calculator out and take 196 and divide it by 28, I think you'll come up with 7. So we have a greater than plus 7. Now, we could leave the plus in it like that and just put the such that line, and the variable is a in front, and then put the curly brackets, and there we go. We could leave it just like that as our set builder notation for the answer. Okay, well, one last example to look at here, and we're going to have variables in both sides on this one. Notice on the left side I've got negative 37 minus 5x. There's no parens over here to clean up, but over on the right side there is. I've got to take this 3 and distribute it into both of these. So 3 times negative 6x will give me negative 18x. 3 times plus 5 will give me plus 15. Okay, I've cleaned up the right side. The left side I can just rewrite here the way it was. There's nothing to clean up, no parens in here. So let's make sure I've got this correct. Negative 37 minus 5x. I left the inequality the way it is because we were just cleaning up each side individually here. Negative 18x plus 15. Okay. Well now, let's identify who has to move. Again, x's variables, or x in our case, are okay on the left. we'll have to move the negative 37. Over on the right side, we just want plain numbers. The plus 15 is a plain number, it's good, but the negative 18x is on the wrong side. We have to move that back to the left. So we got two guys to move here. Okay, the negative 37 comes over as positive 37, and the negative 18x comes over as positive 18x. Now let's double check that we've got the sign changes done. Negative 37 became positive 37. Okay, that looks good. And then negative 18x becomes positive 18x. Okay, we change the sign on it. Plus 18x minus 5x looks like positive wins by 13. So we end up with positive 13x. Now notice, we're just moving things here. And you never flip the inequality when you move things, so I leave the inequality the same way. Let's see, what do we end up with here? 40 and 12, looks like we end up with 52, I think, on the right side. Okay, well, we're only one step away from the answer in this guy. I've got 13x, I just want to have the answer for 1x, so that means I've got to divide both sides here by 13. And now notice, 13 is a positive value, so we don't have to flip that inequality. So we're going to leave it exactly the way it is, x less than equal, and 52 divided by 13 comes out to be, I think it's 4. So there we go, x less than equal to 4. And of course, making set builder notation is easy. Put that vertical set line, our variable's x, write that in front, and then put the curly brackets around the whole thing. There we go. All the x's such that x is less than or equal to 4.